Well, what I have on the board here are the graphs of several functions, and we're going to inspect them visually to try to get a better feel for what the critical points are and what the extrema are. Now, this doesn't replace a rigorous study, but this will give you great intuition about what to expect when you sit down and analyze the functions underneath. So, in the first case, what I've got is a function that goes from -3 to 3. At least we're only analyzing that piece. But it has these holes here, which means that it never really gets there. It's not defined on the edges. It's only defined on the open interval. But what I do notice is I have down here what looks like a minimum. So if I wanted to identify a critical number is where that derivative is going to be 0. Well, you notice the tangent line, the slope of the tangent line is 0 there. So the critical number is x equals 0. Now, do we have any absolute minimums, local minimums? Do we have any absolute maximums, anything like that? Well, I don't seem to have any maximum because while I can walk up, I never actually hit either of those numbers. So I don't have any global maxima. What I do have, I at least have a local minima here. I have to be local because at least in some region, it's the smallest piece. And it turns out that for our function, if this is the world, our global minima is also at x equals 0. And that's sort of the simple case. A more complicated case is here. What I notice is it's not defined on the endpoints. It's not even defined here. It is defined here. So what I'm going to do is, all right, it looks like the slope of the tangent line is 0 here. And it looks like it goes down and comes up, but it looks like it's not going to be defined there. You're going to kind of have a spike. It looks like it's also not going to be defined here or here. It might be defined here. It is, but the graph is so ugly it's hard to know. So when I look at all the different critical numbers, and this is a terrible marker. When I look at all the critical numbers, it looks like -2, so -2, 0, 1, 2, and 3. So I have a significant number of critical numbers. Now, do I have any relative minima? All right, do I have any places where locally it's a minimum? Well, looks like this might have a local minimum, except the function's not actually defined there. So there's no place, because if I picked any other point, I can't pick the bottom, because no matter where I pick, I could technically go a little bit lower, because I can't pick this actual bottom point. So I don't have a local minimum there. I do have a local minimum here. And I actually have an absolute minimum there too, because nothing is lower than that at that point. Now up here, these look like these are supposed to be the same height. They may not be, but they're supposed to be the same height. So up here, these two are the tallest peaks. So my absolute maxima happen at -2 and +3. And my relative maxima happen at -2, +1, and 3. So we get this extra piece here because in this little region, it is the king of its own little hill. So this one's got a lot of points in it, but you can break them down into each piece. Now over here is an even trickier one. So what I notice is that the slope of the tangent line is going up, 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 up. So it's always going up, but it kind of comes up, pitches down to 0, and then pitches back up. It actually pitches to 0 there, right in the middle. That's tricky. So what you actually have is a critical number at 0, at x equals 0. However, you notice how it's always just going up or 0, so there's no change, there's no point where it goes up and then comes down. So you don't have any local maxima or minima because it's always going up. There's always a value that's larger, there's always a value that's smaller. So in that case, you would have no extrema. Anyway, but these are some examples of functions or graphs of functions that you would want to inspect. And when we get to the functions themselves and how to find those critical numbers, it'll become more clear, more straightforward how to get there from the functions.